Let's take a look at this particular law of sines problem. And to do this, we're going to go ahead and set up the law of sines like this. We have the sine of 30 degrees over 20 radical 2 is going to equal the sine of c over 40. So it's always the side opposite the angle. You set up your ratio that way. We all know the sine of 30 degrees is 1/2, and so let's go ahead and just put that in there. It's 1/2 all over 20 radical 2 is equal to the sine of c over 40. Multiply both sides by 40, and that will give you, I guess I could work my way down here. So that'll give you 1/2 times 40 all over 20 radical 2 is equal to the sine of c. I don't want to belabor this because I know that algebra is a problem, but 1/2 of 40 is 20, and then you cancel the 20s, and so you end up with just 1 over radical 2 is the sine of c. Hopefully you recognize that. That's equal to 45 degrees, so c is 45 degrees. Now, here's the trick, or the issue with the side angle situation. So here's, that's what we're dealing with here. You'll notice we have side angle. Don't read it in that order. But so side angle, what happens is that you end up with sometimes getting the wrong answer based on other information about the problem. You can look at this, and if I told you that this was a 45-degree angle, you would say, you know, you're probably wrong. I mean, you can visually see that either you've drawn the picture wrong or that's not the correct answer. The reason for this is because in this case, this if you can imagine this side, the side that we might call side A, that side could be pointing a different direction. And in fact, the triangle that I have over here is exactly the same measurements. It's exactly the same side angle. However, you can see that the side is jutting off to the other direction, and it's all correct. I mean, all the numbers are correct, but this would be more of a, you know, you'd say, okay, that's probably, you know, going to be 45 degrees here. So that begs the question, what is this angle? If this isn't 45 degrees, then what is it? Well, as you know, from your knowledge of the unit circle, let's see, everything is positive up here, only the sine is positive here, that there are angles in the second quadrant that have positive sines. And so the sine so here's the 45-degree angle. This angle here also has a sine of 1 over radical 2. And that's going to be 135 degrees because this is the reference angle is 45 degrees. So this is 135. So that's the angle here. So whenever you have side angle, there are several possibilities. We went over these in class. Here there's only one triangle. I won't go back and you know, deal with all of these, but here there's only one triangle. If you must, you know, triangle, you know, if you really want to know a formula, the deal is that when the side, so we'll label this as A, and this will be B. And so whenever A is equal to, let's see, B times the sine of alpha, we'll call it, or I guess we're using capital letters here. So whenever this happens, you end up with exactly one triangle. And I mean, one way to look at this is that this thing has to stretch its way to this side over here. And the only way it can do that, you know, if it's exactly the right distance, then this ends up being a right angle. But anyway, so whenever A is equal to exactly B times sine of A, you get a single triangle. In this case, you can do the math. It turns out that A, here's A again, here's, I'm sorry, this is C. Let me go back. we've got a B over there. That's C. Okay, whenever A is less than C times sine of A, oh, I see what happened there. I got distracted. Okay, so when little a is less than little c times the sine of capital A, call that capital A, then there's no triangle. But then in this case here, you have the situation where little a is bigger than little c times the sine of capital A. And in that case, you end up with two triangles. Which one is correct? Well, it depends. If we're dealing with an application problem, then you would pick the one that makes the most sense for the application. Some applications, maybe the obtuse angle, the 135 would be correct, or maybe the 45. Just depends on what the situation is. If there is no other information given about the problem, then both of them are correct. You have two solutions. You've experienced this in other settings, and that's just the way it is. I mean, once you have that angle, so in this case, the angle B, let's see, 135 plus 30 is 165, so B has to be 15 degrees. And then we could figure out what little b is using the law of sine, so I'm not going to do that in this video. Here, though, what do we have here? 75 degrees, so B has to be 105 degrees. So it's just a completely different triangle. You have two solutions for the same problem. So there you have it, side-side angle.